Good evening, Aisha.
Good evening, sir.
My name is Benard. I'm a chemical engineer by profession, and I'm also the founder and managing director of Apple Vision Limited, which is a consulting and engineering company in Uganda. I worked in the pharmaceutical manufacturing industry for 6 years before I moved to the service industry. I'm really very excited by what you've just talked about, and you've confirmed to me that we go to school to get knowledge, skills, and then we apply them. I've liked the way you've articulated that information. Now, I have a few questions that I would like to discuss with you. I don't want to say I'm going to ask you. We are going to discuss. From your introduction, you talked about team management. And that has confirmed to me that as chemical engineers, we are trained to become engineering leaders and managers, right?
Yes.
What's the difference between a leader and a manager?
The difference, according to me, between a leader and a manager is that a leader is basically quoted or is basically given the responsibility, like that you have to do this, or you have to govern or lead a particular number of people. But a manager is, I don't think so that he is like quoted or given a particular position. He can be among the people. Because there is a quote that not a quote, but a learning that I recently learned, that you don't have to have the authority, or you don't have to become a leader in order to lead a number of people, or in order to manage a number of people. You can take that responsibility by yourself as well. So I guess that manager is that one who is not quoted or who is not given a particular responsibility. He takes that by himself. Whereas a leader is, I guess, quoted, and maybe I think I'm wrong. I'm not sure.
Why are you doubting your answer?
I am doubting my answer because because I think so that because both are quoted. That is the reason why you call them managers and leaders. So that's why maybe I'm wrong.
Oh, the two terms are the same.
Yeah.
Is it true? Are they the same? Is a leader a manager? Or is a manager a leader?
Yes, both of the terms are same, I guess. Yeah, I conclude them that it's same. Yes, I'm sure.
No, they are different.
Okay.
They are different. Just like you had tried to explain, you brought it right. A leader persuades the team to achieve a goal, and the leader knows how to achieve the goal and leads by an example. Okay? Unlike a manager who gives instructions that at the end of the day, we need to achieve a profit margin of 100,000 US dollars. How to achieve that is none of his business. Okay?
Okay.
So you explained well. So I would like to share or to understand your experience in team management. You said you worked in was it industrial training in the pharmaceutical industry?
Basically, I work in teams in both, like in the group projects in my university as well, and also in group projects in industries as well.
Okay, from the perspective of group projects that you've been engaged in, what are some of the challenges you faced in working as a group? And how did you overcome those challenges?
Okay, so basically the challenges that I usually face is that my point of view is actually quite different from that of the other team members. This is the first problem. Second problem is basically that due to some tragedies or due to some problems, sometimes I don't get such members that are exactly according to my pace or according to the requirements that I want them to be. These are the two basic problems. Like, they don't work according to my time management. They don't work according to what I tell them. So I managed the two things in such a way that first of all, when it was very initial phase and when I did not know about anything, at that times I had problems. But then later on, I understand that if they are not trying to understand my perspective, I have to change the way that I am explaining them things, because maybe there is something wrong in the way that I'm explaining to them. That's why they're not understanding. So I basically made my way much more simpler and much more easier. And I used to use, maybe I'm doing it right now as well, but I used to use long sentences. So, and the other person was like completely confused or roaming in what I was studying to him or her. But then I made my sentences concise and I made them cut shorter. And then the other point was that I started to observe and I started to listen more to others as well. That helped me to communicate and to bring on my perspective and also to understand their perspective as well. The other thing was that, as I already told, that I do not usually get good members due to some things. So I tell them that these are my requirements and these are what I want from you. And then I give them a whole of plan that you can do this, and with the help of this type of time management, this type of planning and doing like when you provide others the whole way, the whole path very clearly, then they can easily walk on that. So that is how I manage those types of people who are not that good in not technically nor any other. So not from any other aspect. So I provide them things and provide them details, complete refined details. That helps them a lot.
That's so wonderful. Now, in the pharmaceutical, which kind of projects did you work on in the pharmaceutical industry?
In the pharmaceutical industry?
Yes, which project did you work on?
Okay, so in the pharmaceutical industry, it was that they had a tablet coating machine, and it was a batch reactor or a batch machine. So we had to convert that batch tablet coating machine into a continuous tablet coating machine. And we did that with the help of two other mechanical engineers. They worked on SolidWorks, and me and another one of my companions, we basically performed all the calculations and all the flow-wise calculations, etc.
Which problem were you solving?
Which problem?
Oh, yes, which problem were you solving? Why did you take up that project to convert the batch reactor to a continuous reactor?
Oh, okay. So what was the problem statement? So basically, we went on the internship or to the industry, and they were basically facing this problem that in the pharmaceutical industry, like first when the tablet is first made when the punching of the tablet is done, it is then brought in. It is then like put into buckets, and from the buckets it is then brought to the coating area. So in the pharmaceutical industry, you can obviously, what they do is that they minimize the contact with the tablets, and they minimize the contact with the tablets. One was this thing. So in order to minimize the contact with the tablets, what had to be done was that when the tablets are made and when the tablets are punched and when they are shaped, they must be directly brought into the coating machine rather than being brought by hand, being first put into the buckets and then brought from the buckets to the machine. So there had to be a conveyor, or there had to be a covered conveyor or covered sliding something. That is the reason why the batch had to be converted to continuous. The other reason was the time and was the cost. We know that when the process is done in the continuous reactors or continuous machines, then the time is less as compared to that of the batch one, and the cost is also less, and the labor work or the amount of labor that is used, that was also less in the continuous one. That is the reason why they had to have the continuous one.
As a chemical engineer, how did you approach that problem? How did you convince the management to accept you to undertake that project? And how did you arrive at the solution?
Okay, so first of all, we were very much, this question has basically two parts. So first part of your question is the answer to that is it's not like a final year project that you have to make a proposal and then you have to bring it up to the management and they will accept it. It wasn't like that. It was that on our summers, in our summers, we went to the industry, and that industry had this problem, so they gave us this problem by themselves. So, and the second answer is basically that first of all, we did not even have any idea that from where should we start. So first we did a whole scenario of the whole of the industry. We first understood all of the processes. Then we spend 2 to 3 days in the coating area, and then we realized that how should we start our project. This much was already understood, that there is a need of a conveyor so that you can directly bring the tablets from the punching to the coating site. This was already understood, but the problem was how to develop the machine, how to develop the rotation time. Should it be a linear one or should it be a screw motion? Should it have a screw motion, etc. So then what we did was that we first got the data of the tablets, that what is the size of the tablets, what is the thickness of the coating, and how much amount of coat must be required by one tablet, etc. We got all that data, and with the help of the formulas that with the help of different formulas of the flow, of the weight, etc., we realized that in a particular amount of time how much tablets must be coated, or what is the requirement according to them, and then what should be the area of the machine, of the tablet coating machine, what should be the time, what should be the rotation, etc. So with the help of, we required a lot of help of the mechanical engineers as well. But from our side, the study was based on the data collected about the thickness, about the time, about the weight. Basically the work was basically on the weight of the tablet, like before coating and after coating and etc. The equations were based on that.
Before proceeding with that project, did you do some feasibility study or analysis?
Some feasibility study or the analysis of the already going project, already going process?
You had to do, there was that old process that you wanted to change, and then the new one that you were proposing. Did you do some feasibility analysis for the two?
Feasibility analysis. Well, it was actually a project that we had to change. Well, the thing was already there, but we had to change, because we had to change the aspects of the thing, and we did a scenario. Yes, a scenario was done in order to collect the data. Sorry, the feasibility scenario.
What I'm trying to mean, okay, for the new project that you did you do some feasibility study on it to check if it was better than the old one?
We did not perform the feasibility study like before, but we did the validation of our project afterwards by running it on like SolidWorks. There's a software SolidWorks, so we ran our equipment on the SolidWorks and we observed that is it feasible or not, but we did not perform it before. We did the validation part, but not the feasibility.
Because I'm wondering, how did you gain the confidence that the new proposed project would be better than the old one from an economic perspective?
So basically, the confidence was actually gained because of the supervisor that was already working there, already working in the industry. He basically provided us that you have to make a continuous machine rather than the batch one. So the confidence was basically provided by him.
Okay. Now, while executing that project, which chemical engineering skills did you apply to arrive to that solution?
The chemical engineering skills that we applied was, I don't remember the exact equations, but the most of the work was basically performed on the weight analysis and the movement of the and the movement of the sprayed tablets all around the coating drum. So basically the equations of the weight and the equations of the flow were basically applied.
Yes, exactly. That's what I wanted to hear. Now, you know, chemical engineers, they are trained as problem solvers. They are able to identify a problem and then develop solutions. And in the process, they do modeling. After modeling, they do simulation. Okay? And
Yes.
then eventually, when they get the solution, they can go ahead to optimize. Did you do any of this?
We did the problem identification part. Then we did the simulation part. We did not perform the optimization part. Optimization is basically then performed that you already have a process that is like working, and then you perform the optimization, you cut down the parameters so that the already process is much more efficient in all the aspects about in accordance with the energy, in accordance with the cost, etc. So we did perform it like no, we didn't perform the optimization part, but the rest of the steps we did perform.
What happened during modeling?
During modeling, during modeling, it was that we had a number of structures. We had like, should we go with the screw type of the drum? Should we go with such a drum that does not has a screw motion in it, or the screw conveyor, or the screws like you know, with the walls of the drum? Should there be screws or should there not be screws? So we performed it like on the SolidWorks. We used like, first we used a plain drum, and then we used to change the diameters of the drum. We used to change the length of the drum. We used to change the time of the motion of the drum. So we used to see all of these changes, basically which values of these parameters or of these conditions are most suitable for us. So that is how we perform modeling. We didn't do it like on HYSYS.
Meaning at modeling, you developed some mathematical equations that represented the actual process.
The thing which I was telling you, we basically developed some structures as well, but according to the modeling equations, we did modeling according to the equations as well, which I already told about the weight ones and about the flow ones, about the time ones.
Okay, so what was the outcome of that project?
The outcome of the project was basically a machine. Okay, so a machine in which there was a machine in which from the inlet there was a conveyor, from the outlet there was a conveyor. The machine had a rotation. The machine had screws in its walls, and then the goal that they provided, that this much amount of the tablets must be coated in this much time. We basically did a little much above that, so that the difference can be seen. And safety was also safety analysis was also done on that. And the outcome wasn't a physical machine. It was a machine on the SolidWorks. It wasn't a physical created machine.
Oh, did the management accept to take? Yes.
Benard, how many minutes you will take further?
Like 2.
Okay, thank you.
Please. Did management accept to implement this new solution that you provided?
The management in front of us, the time at which we presented a whole of the presentation, at the end they said in front of us that they will implement that, and they were like, okay, this is achievable, and this is like this is realistic, and in front of us they accepted that they will implement it. But right now I am not aware that is it implemented or not. Okay. But we did write a paper on it as well. From
this interaction, I've realized you are good at identifying and providing solutions to problems. But now today, as I wonder, there is this problem that is affecting the entire world, the problem of climate change. And from an engineering perspective, industrial processes that are producing some of these greenhouse gases are a contributing factor. Is that true? As a chemical engineer, what do you think we need to do to reduce?
What I think that we should do, basically my FIV project that was, I guess, already told to you by one of the companions. Our FIV project is also based on these types of emissions. Like it's basically a carbon dioxide capture from the natural gas, right? So we want to decrease the amount of carbon dioxide that is already present in the found out natural gas. So as an engineer, what we should do is that what we usually do is that our main focus or our main goal is basically most of the time just the cost, right? That the cost must be decreased. That is the job of an engineer. But it must be brought into more of action or more of application, that you are much more concerned about the environment, about the emissions as well, as much as you are concerned about the cost. So if that thing is like brought up as such a factor that is like extremely important, and that it must be brought up as a first priority, then I guess much more processes will be performed in which the emissions are reduced.
Thank you for the confidence and your experience and skills.
Okay. You're welcome.
Back to Hassan.